go ahead and do a little bit more extra practice. Let's give 13 and 14 a try here. All right, so number 13. So when I'm looking at that, I'm thinking we're ready to go because of the fact that 9 is divisible by 3 and 27 is a perfect cube. So I'm going to go ahead and just go for this here. So what's the cube root of 27? 3. And now, let's get this out of the way here. How about this q to the 9th? Now remember how you could think of that would be q to the 9/3, which is 3, right? So there you go. Here's the answer to that problem. So over to number 14. Okay, so let's think about what could you do here? Lots of things. Here's one example. Let's break this up as fifth roots. There's just one way to do this. And then, I guess we could think of this written in rational exponent form. Isn't that 10 fifths right there? Which is 2, isn't it? Yeah. And how about this y down here? Isn't that 5 fifths, which is 1? There's the answer. Makes it pretty easy. That's just one way to do this, though. I mean, it can be done different ways. Okay, how about everybody thinks about those problems and the way you would do them? All right, for number 15, I guess what I would do is get ready to do this problem and perhaps highlight some things about the numbers. 6 divided by 3 is 2, right? Now maybe we can look at the x's, if I can get that highlighted correctly. Now remember, this x here is a first power. So you can subtract your exponents. 1 minus a half would be a half, wouldn't it? So this would be x to the 1/2. And then finally, how about the y's? And since they're being divided, we can subtract them. So that'd be y to the 3/4 minus 1/2. That's like 2/4. So the 3/4 minus 2/4, 1/4. And there would be a 1 left behind, but I guess we don't even need that, do we? And we don't really need that fraction bar. So I guess there's our answer right there. All right, let's head on to number 16. So I'm looking at these two radicals, and we got a problem. This radical and that radical, they're not the same. So we cannot subtract them right now the way they look. So I think what I'm going to do is I'm going to try to rewrite these. So this radical, I'm going to break it into perfect square roots and non-perfect square roots. And I think I'm going to try to do that over here as well. Okay, so let's think about this right here. How about that 9? Can you get a square root out of 9? You sure can. I'm going to put that right here. Okay, next thing. How about that w to the 5th? That's not divisible by 2. Remember, this index is a 2 right here, right? So what I'm going to do is I'm I'm going to put a W fourth here, which is divisible by 2, and a W to the first right here. And that's going to work out for me. Now I'm going to go over here and look at W third. Same thing goes. 3 is not divisible by 2, but W to the second is, and there's W to the first. That makes W to the third. So let's see what we get here. Square root of that would be 3, and then 4 divided by that 2 is 2. Now I've got this radical. Okay. Then over here, I've got minus W. What's the square root of W squared? Is W. That's W squared. Okay, you see what's going on? So you basically have 3 minus 1, 2 W squareds, radical W, final answer.